Welcome back to the office. We want to take a look at a non-example of a group. And what we're going to do is we're actually going to refer back to a binary structure that we took a look at in section, let's see here. Got to grab onto my old notes here. This is section 2 that we looked at binary structures. So I'm taking a look at a binary structure. Maybe we want to specify first that G is going to be the set of elements A, B, and C. Doesn't really matter what we call them. But for this operation star, this binary operation, let's see here, I want to take A, B, and C, A, B, and C, kind of create this nice table. Okay, here we are. And then I said that we are defining this binary operation to give us A, B, C, B, C, B, A, C. And so we talked about commutativity, not commutativity, and we were able to observe here that this is not commutative, and that's fine. Binary structures themselves don't have to be associative. And so that's one way that we can fail to be a group, right? What we have to do is, in order to not be a group, we have to fail the definition of a group. We have to take a binary structure. We could fail to be a binary structure. Well, you'd have to look back to look and see what it would mean to fail to be a binary structure. Mostly that has to do with being well defined or not, or closure. So we need closure and we need well defined, right? That's what this is saying. So we're assuming closure and well defined. Once we have that, we have to satisfy the three characteristics of associativity, identity, and inverses. So if you fail any one of them, then you fail to be a group. If you fail any number of them, you fail to be a group. So 1, 2, or 3, any of them, right? Any number of them, that is. So let's just look in this case, trying to focus on one thing. Let's see, could we could pretty easily show that there's not an identity here. It's true. We could probably show pretty easily that there's no inverses. If there's no identity, there can't be any inverses. So we certainly fail those things. But in this case, I also wanted to point out that it fails associativity. Now, it doesn't fail associativity for every three. If I take A star, B star, C, right, doing A and B first, and then observe that A starred with the quantity B star C, that actually simplifies and everything works out very nicely and it appears to be associative. But the point is that with any three elements. So if I were to take, let's see here, I've got this written down somewhere. Here it is. If I were to take A star A and then star that with C, this is going to be equal to, so I'm going to do two things here. So A star A gives me back A, star that with C. Now A star C gives me B. Fantastic. What if I do A star C? What if I do it in this order? Well, I have A star. Now A star C gives me B, and A star B gives me B. A. So I was nervous there for a second. It gives me back A. There we are. A star B gives me A right there, that thing. So here, grouping it this way, I get B. But grouping it this way, it gives me A. These two things are not equal. They're not equal, so star here is not associative. It's not associative. So in this case, what we're looking at, G star is not a group. We gave it as an example of a binary operation, a binary structure, but it is not a group in this case. Again, we are demonstrating that it's not associative, so it's failing the first characteristic or the first axiom. Now, it also fails the other two, but all we have to do is verify that one is not satisfied. So in how many ways can we fail to be a group? Well, fail any number of these things. You can fail 1, you can fail 2, you can fail 3. So if you want to talk about your counting techniques, essentially you should find that there are 7 different ways that you can fail to be a group. All that matters is that you failed 1. So as soon as you can observe that 1 is failed, you have that it's not a group. It doesn't matter if it fails all 3. All right, so again, there's an example of a binary structure that is not a group. Fantastic. All right, so we're going to take a look at some more things related to groups in our next video. So I'll see you guys back in the office in just a moment.